Is it blocking anybody?
What?
Is it blocking anybody?
No. Sort of. Yeah. Like, I mean, we can see you on the screen. We can see the screen, but like.
Can you move? Can move.
But I'll be fine.
Okay, so we're going to talk about chain rule. The chain rule. When do we use chain rule? So those are the questions that when do we use chain rule? Always. So no. When do we use chain rule?
He said always. This is funny.
Wow, my handwriting's getting a lot better.
Oh wait, Mr. Ye. Mr. Ye, I never finished.
Wait until get to differentiable. Okay, so when do we use chain rule? So here is this question. Do I need to use chain rule here?
Yeah, you gotta explain what chain rule is.
Yeah, but do I need any other rules that you don't know of that take derivative of this one functions? No, right? So it's going to be like y prime is equal to 2x, right? So that's just a power rule because derivative 1 is going to be x. So now I'm going to show you the chain rule. So the basic thing is the chain rule is used to parenthesis to any other power than 1. Any power other than 1. Okay? It's a parenthesis to any other power other than 1. You can use chain rule. Okay. So for example, so I will say parenthesis with any other power then 1. I do know how to spell parenthesis. Are you testing me? P-A-R-E then T-H-S-I.
That's wrong.
You tried. That ain't it. But you tried.
Parenthesis.
Why is there All right.
Leave it alone. Jesus. Okay, parenthesis with any other power than 1. So what I'm saying is this. So what is this? This parenthesis to what? Which power? 1/2 power, right? So those are the things. Maybe x squared minus 1 to the 7/3, something like this. This is other than 1. So if it's 1, then I can just take derivative. This is parenthesis to the 1 power, right? This is a parenthesis other than 1. Okay, if it's 2, 3, 4, 5, 6, 7, -10, -2000, they are all other power than 1. So that's when you use chain rule. So we're going to talk about definition goes. So the chain rule, and we're going to assume that y, so they are composite functions. Composite function, do you have some homework question there? That's in terms of composite function. F of a g, right? F of g of x, we call it Fogg function. Right? And we got a Gauss function, hg of f of functions. You guys seen that before, right? Hopefully. Yeah. If you combine both together, it will be f of a g of f, right? So it's going to be Fogg off. Fogg off. That's my new shirt. That's my new shirt. It's f of g of f. That's my, I'm gonna monetize that.
Oh, I get it because you're Asian and instead of pronouncing it, you go.
This is live. Okay. So now we're gonna talk about, is it recording? Okay. Okay, dy dx, we're gonna say y, now this one I didn't really name it, it's actually from the textbook, it's f of u.
All right, you all did that.
I swear. No, I swear. It's f of u.
Mr. Ye, I never did the graph. I need the graph. I need the second graph.
I don't know the graph, so you're good luck. So what we're gonna do is we're gonna take a derivative of this, and we're gonna say u is equal to g of x. We're gonna say u is equal to g of x. okay, g of x. And we're gonna say y equal to f of u is differentiable. Again, I don't know how to spell differentiable, so I'm gonna
Just put a dot.
There you go, differentiable. Okay, so we're gonna give you a formal definition. The formal definition looks like this: dy dx is equal to dy du times du dx. Now this one's a really hard definition to think about, but for competition that we use this sometimes. Okay, so for a better definition is this one, is determined by composite function, so it'd be d to the dx of f of g of x. Okay, so if I take a derivative of this function, I'm gonna get derivative of the outer function, which is f prime of g of x. Now parenthesis, right? See the parenthesis, how the parenthesis is aligned? Okay, so now it's gonna be g prime of x. So this one's a little bit harder for a lot of students. You can change your C if you want. Sarah, you can change your C also. Joseph, you can change your C. Okay?
It's okay. Well done.
So basically, there is an outer function, there's an inner function. So you can, if you really want to color code this, let me use color coding. So that's something pretty important. If you can color code it, the student can understand. So it's f of g of x. So we're going to say g of x is inside. Questions? Okay.
No, you're
So let's talk about composite function.
That's some creativity.
This is a joke all along.
You want me to color code as G2? I can color code as
The one above two. This is color code everything.
He
changes
everything to red.
Color code.
Hey, leave me alone. Okay, so yeah, that's very beautiful. Thank you. Sarah. I'm learning to color code. Okay, so now
Wait, what?
except now we're gonna say let's break the function down. Let's decompose the function. So if I have f of g of x is equal to 1 over x plus 1, what will be g of x is and what will be f of x in this case? So you guys have to think about it. And so if I were to decompose a function, I'm going to decompose. That means I'm going to break two different functions. One's a g of x, one's a f of x, and we want to break the different parts. Now you guys want to see this. So what will be the function in this case? So I'm going to call somebody, Daniel. G of x is going to be what? Huh? X plus 1? Okay, good. Okay, so what will be f of x going to be Abaya. Did I pronounce your name right?
Yeah.
Okay, so what will be f of x here?
1.
No, that's not 1. 1 over what? No. Maya?
1 over x.
Good, 1 over x.
The only option.
So if you think about it, right? So let's do f of g of x in this case. F of g of x is equal to f to the, well, this one's x plus 1. So I'm going to plug in x plus 1 into here, so it'll be 1 over x plus 1. So that's equal to this, f of g of x, which is true. Okay, so I'm going to give you a few other functions. You guys are going to debate. And sometimes it can be a lot of different options. So we're going to give you this one, sine of 2x. Okay, we're going to give you a sine of 2x. I'm going to ask you to break down. So this part, I'm gonna erase this part. So I'm gonna say sine of 2x, that's gonna be what it would be for g of x, and maybe square root of x squared minus 2x, and maybe 10 square of x. So you're gonna figure out what is g of x, what is f of x here.
Yeah.
Please grade it though. Please grade it. Wait, you just need to grade it on the last. Wait, Bobby, did you do the front page?
No.
Bobby,
I don't know how to do it. I wasn't here.
Did you even attempt?
No.
So Bobby is like the whole period, right? He worked only one front page, or two front page, and he didn't know there's a back page to the page.
Bobby,
And
you're not gonna get a 70 if you
and
do
the
this.
second half of the period, he screamed. He's like, "Holy crap! There's another page on the other side." Okay, so what will be g of x here on this one and on this one? So I'm gonna call on you guys Moniac. What will be g of x here and what will be f of x here? What is it? 2x? Is that right? Okay. And Moniac, what will be what will be f of x here? Sine? That's it? Sine what? There you go. Okay? So that's how you decompose the functions. Okay, you learned this in Ms. Nguyen's class and Mr. P's class, I believe.
No, we did not. No.
Okay. But Ms. Nguyen definitely does. Ms. Nguyen definitely does. Okay, so what will be g of x here?
Bobby, did you get it now or no?
But this is the most I've ever answered on the test.
So, it's a quest.
It's a quest.
Okay, so we've got a lot of things to do. So what will be a function here? Somebody help me. Natasha.
Is it x minus?
Elizabeth? Alden? X squared minus 2x. Good.
Bro.
Okay.
What would be f of x?
Whoa. Other things. I don't actually.
Okay, no, this is just the easy part. Okay, so
Let's go 5.
This is crazy.
okay, so 10 square of x. Here you can sit down here to watch.
Okay, can I log in my hours?
No. So 10 square of x here. What will be the function? G of x. 10x. Good. And what will be this one? X squared. Perfect. Now you guys understand the composite function. At least you know how to decompose a function. So decompose a function. So now we're going to talk about the general power rule. So we're going to talk about this rules here. So it looks like it's like a u, f of a u, and then you're going to take derivative of a u, and then it's actually reverse of u substitution. So your homework today is going to be expanding this equal to x minus 7 to the 10th power.
Maybe expand that from
No, I'm just kidding. No, you can actually expand that with binomial theorem.
Do it.
Um,
Just use Pascal theorem.
And then you can do it with a Pascal triangle.
It's so easy. Take a while.
But just take a while. But the thing is, we're not asking you to expand this. We ask you to take a derivative of this. So derivative of this, just imagine that I'm gonna color code this again.
Okay, great.
X minus 7. I love color code now.
Now we're gonna get
Try
a whole
different
new pack of
colors.
mushrooms.
So u is equal to x minus 7. Okay, so what we're gonna do is u is here. It's f of x is x minus 7, right? No, g of x is x minus 7, and then f of x is x to the 10th power, right? So remember, we're going to take a derivative of a function. How do I take a derivative of a function? D to the dx of f of g of x is equal to f prime of g of x, right? Which is, this part is u, and then times g prime of x. And then you say, okay, I can take a derivative of that. This one just pretty much, this is u to the 10th power, would you say?
I agree.
Okay, that's u to the 10th power, right? Now, if I were to take a derivative of this, I'm going to do y prime, which is derivative. That's another way to write something. So y prime, this one is equal to, well, if this is u to the 10, how do I take derivative of u to the 10? 10 u, which is x minus 7. Maybe I should color code this.
With this red and purple.
X minus 7, right? And then to the 9th power. And then I'm going to take a derivative of the x, which is what? Derivative of x is 1. That make sense?
I get it.
Okay?
You have to explain.
You don't have to explain that. Okay, so let me give you another one. So y is equal to, let me say, okay, 3 minus 6x squared to the 7 power. Okay, so I want to take a derivative of this. How do I take a derivative?
What is that?
It would be 7.
Write it down, use a paper and pencil and not on my papers.
Oh, that's my paper.
I literally just got
Yeah, mine now.
It's my brain.
Can you use your own? Can you go sit somewhere else and use your own paper?
Bobby, come here.
Oh, looks like I have to go. Yeah.
Why?
Pictures for you, but
Oh, this one's recorded, please do one. Okay, so if I were to take derivative of this, it's u to the 7th power, right? So y prime, u to the 7th power. Let's take derivative of u to the 7th power first. It'll be 7 u to the 6th power. Now I have the derivative of the inside. What will be derivative of the inside? Times negative 12x.
And that's it? That's
So,
like your.
well, you can simplify this. It's 72, 12 times 7 is equal to 84. So it'll be negative 84x. And times 3 minus 6x squared to the 6th power. Okay? Are we okay here? Okay, so now we're going to go into the little bit harder one.
Oh, like 3 functions?
No, not yet.
No.
So let's go with the y is equal to, okay, let me give you this.
Feeling ambitious?
What is that?
Getting spicy.
10 squared? 4x minus 5x squared. 5x squared.
So think about algebra first before you do calculus, always. Remember that secant x and cotangent x,
Yeah. You have to think of algebra 1, then geometry.
and the trigonometry, and then calculus.
And then algebra 2, and then calculus. You can't skip geometry, because what if it's like corresponding?
Corresponding angle.
This one here is algebra 2.
Oh, yeah, that's not happening.
So if I were to do algebra first, do I like radical in this case? Can I take a derivative of radical? Now what can we do? Power over roots, right?
Crazy.
What? The cube root of 4x minus 5x squared, and then squared.
So it'll be what? 2 over 3. Does that make sense? So now I'm going to take a derivative of this special power here. They don't have to be integers. They can have fractions. So if I take a derivative of this, y prime, make sure you get a habit. When you take a derivative, you do y prime. So that meant that one, you know, this part is only take a derivative part. This is the only part is calculus. So if I take 2 thirds in the front, times 4x minus 5x squared to the negative 1/3. Am I doing okay? Am I done?
No.
Most of you guys on the test, this is done. I promise you, this is what happened, but I'm going to tell you, you have to take a derivative of the inner function now, which is going to be 4 minus 10x. And then that one I can rewrite because I don't have negative exponent. I don't like radical, but I don't like negative exponent. So I'll write on the bottom. So it'll be 2 times 4 minus 10x. And then 3 times 4x minus 5x to the square to the 1/3 power. I don't want to put radical. I can, but I don't want to leave anything radical term now. I'd rather deal with the rational exponents. How about this one? Now I start with the fx instead of y, so what do you think when you take derivative is going to be? So let's just start with a -2 over, I don't know, 3 minus 2x squared to the 4th power.
Wait, for that one, you don't want to like multiply it out.
Effective form is the best. This is our effective form already. So, yeah, -2x to the 4th power. So, remember, yes, you can think about quotient rule, but here it's not a key. You don't do quotient rule when the top part is a number. Okay, just put that in mind. At least write down on your notes. It says if a numerator is a number, never do quotient rule. For example, on your test, k over x squared. How many does the quotient rule on that one? K over x squared. It was one of the k problem, and you did a quotient rule.
I still got it wrong.
But you don't do quotient rule because the top part is a number. So make sure if top part is equal to number, if numerator is number, equal to number, no quotient rule. Also, if the bottom's one term, don't do quotient rule. You can split them and take a derivative. A lot of you guys did quotient rule on that one too, which is a mess. Okay, so what can I do with these functions?
Put it up and make it negative.
Put it up. There you go. F of x is equal to -2 times 3 minus 2x squared to the -4 power. Now you can take a derivative using a chain rule that's much more effective than anything else. But this is definitely on the test because a lot of people are just going to do wrong thing. And I still put it like the bottom's one term one, because you still have to worry about that one. So I haven't taken a derivative yet. So now I'm going to take a derivative here. F prime of x is equal to -2 times -4 times 3 minus 2x squared to -5 times -4x. Does that make sense? I take it the -4 down in the front. Now I take a derivative of the inside. That's what people forget on the chain rule, because you had to do a derivative of the chain rule. So it'll be -a times -4, like 32x times 3 minus 2x squared to the -5. And that's equal to -2x of 3 minus 2x squared to the 5th power. Let me know if I'm going too fast. Am I going too fast?
Is it 5?
Abaya, is that too fast?
5, you moved it down. Oh, yeah.
Because that's 8 and you multiply by the -4.
Okay, I'm gonna give you one to practice, and before I go to the next part. So this is a one that you want to practice. So if I have -4 to the 3x minus 6x squared to the 3, and this to the 5th roots. So hopefully you can take a derivative of this one. This is a 5 roots here. And then we had to worry about algebra again. We're going to teach you a new algebra skill that you never learned before.
You right. Let's go home and Here, I'm gonna do it. Write it Jesus. Double-sided. So what is it? Oh, so it's not good.
So if you guys got it right, derivative of that, double check with each other, see what you get. I will probably write that function. I'm going to go down here to the 5th root of 3x minus 6x squared to the 3rd power. Did you rewrite it? Did you guys rewrite this?
Yeah.
You got to this part? Abaya, you got it? No? Okay, so now we're going to take a derivative of that part. I'll rewrite to the numerator first. Because the only numerator can do the power rule, not a denominator. Now let's take a derivative of this. Can you guys take a derivative of this? It's equal to what? -4 times by what? -3/5 times by 3x minus 6x squared to the what power? -8/5, right? And then times derivative of a 3 minus 12x. Don't forget about this part. That's what people forget. Do not forget about that part. So that's going to be what? 12/5. It's a positive because this was 1, so that's 12/5 times 3x minus 6x squared to the -8/5 times 3 minus 12x. Now I don't have negative exponent, so I'm going to write it. And that's my final answer. Yes? Yeah, usually we write the negative exponent to down there. I don't want a radical though. A radical is bad, but the rational exponent is okay. But rational exponent is better, prefer to be positive. Any questions? Now this one here is a I'm going to do a 2 here, just kind of fun.
Let's have some fun. Let's play a game.
Huh?
2x cubed, that's the 3rd value, that's what I'll test. Like, 30 minutes straight. Yo, okay, so I brought the 3 down, like 2 times 3 is 8, for 30 minutes.
Okay, so this one, think about which rule are they. So maybe this one I need to color code this one. Is 2x cubed, right? So now What do you know? How many rules I have to apply here? The purple and red, those two different functions, right? So that's what? Lefty, right, righty, left. Okay? And then what happened? This is to which power? One other than 1, right? So what the rule do you have to use when you take it to the chain rule? Okay, good. So this is not a hard part. Okay, let's talk about algebra though. We're going to talk about algebra for a moment right here. And this one that is you guys don't understand is that algebra part they didn't teach you here, so we're going to teach you how to factor out something like this. X to the -4 minus x to the -2. This one's factorable, and you usually factor out a GCF. In this case, it's going to be GCF is going to be -4, but we're going to factor out the negative exponents. Negative exponents. Okay? I'm going to factor out negative exponents here. So I'm going to factor out a more negative. I'm going to factor out a -4 power. Okay? So I'm going to factor out. And then that's going to give you something. Or x to the -4 times 1 equal to x to the -4. 1. Now, how do I do this part though? This part is actually interesting. What do you think is here? So for me, it's always subtract whatever you factor out. So for example, x squared minus x4, right? So I'll factor out x squared, you subtract by 2, right? So that's 1 minus, subtract by 2, it's going to be 4x squared, right? So you subtract the power. But I here is going to subtract the -2, subtract -4 is what?
Plus 4, -2 x squared.
-4 subtract -4. -2 subtract -4
Plus 4.
is x squared.
You gotta put the parentheses.
I did.
Oh, like I'm saying, like you subtract.
Okay, so x to the 5/3 minus x to the 2/3 negative. So which one I want to factor out?
The bigger one, 5/3.
The more negative one. You always factor out a more negative.
5/3.
More negative term. Exponent. Okay, you're going to factor out a more negative exponent. But which one is this case?
I don't even know.
5/3, so it'll be x to the -5/3. This one's more negative than this one, right?
I can't help.
And now what I'm going to get is here, 1. But what's -2/3? What do you think this one says?
Just there.
-2/3 subtract -5/3 is equal to -2/3 plus 5/3.
Right.
That's equal to 3/3. That's equal to 1. So it's actually pretty nice.
Yeah, that's nice. That's clean, bro. That's nice.
Okay.
Did you use that out of the book or you just come up?
No, this has been taught this way for a long time. I mean, since calculus come out. Generations. Marvin, you okay? No, this one.
Oh, what?
Looks sleepy.
Yeah, sorry.
Okay.
But you got like 5 minutes.
5 minutes, good. That's good enough. Okay. So now we're gonna take a derivative of this. There is a left function, there is a right function, but be careful with the right function when you take a derivative. There's a chain rule involved because we're gonna rewrite this. Should I color code this? Probably. 2x to the 3rd, and the purple function is gonna be 4 minus x squared to the 1/2 power. So I'm gonna take a derivative of this. So this one is gonna be red. So it's equal to 6x to the what? Square. Okay? And then we're gonna leave this one alone. 4 minus x squared to the 1/2. We take a derivative of left and leave it left right alone. So I kind of did the other way, but sorry about that. But in the associated property, that doesn't matter. So now I'm gonna leave this. I'm gonna plus. It's gonna use this. So I'm gonna leave the first one alone, which is 2x to the cube, right? And then we're gonna take derivative of this function. Now be careful with this function. So times 1/2 times 4 minus x squared. Now don't forget about this 1/2 subtract 1. So it'd be what?
Negative.
And then I'm done?
No. Inside.
Derivative of 4 minus x squared, which is what?
Negative.
So now I'm going to cancel out one of the 2's because my life is a little bit easier when I do that. Now I'm going to also factor out this, which is this part I'm going to factor out, but which things I'm going to factor out in this case? 4 minus, so we're going to factor out a 4 minus x squared to the 1/2 power. So be 4 minus x squared to the negative 1/2 power. We're going to factor out the most negative part. So this one is going to change into what? I use a bracket here because what do I have left if I factor out negative 1/2? This one's going to be what? 1, so it'll be 4 minus x squared, right? I can factor out this, but I'll factor out later. So 4 minus x squared to the 1 power, because this one changed to 1. Any question about this part? Now what do I have left?
6x squared.
6x squared, right? Minus, well, why is minus? Because the sign, the cubic track is out going to be negative here. This one's completely out. What? So this part is, what do I have left? I have 2x cubed times negative x, right? Minus 2x to the 4th, so let me just use the simplifier here. 2x to the 4th. I can even factor out x squared from here, so I'm going to factor out x squared from here. Actually, I'm factoring out 2x squared from here. So look at this, x squared and x squared. I'm going to factor out 2x squared there. So I'm going to factor out 2x squared times 4 minus x squared to the negative 1/2. Okay, so if I factor out 2x squared, what do I have left? 3 left. And then 4 minus x squared, right? And then 2x squared, what do I have left? Minus what? Minus x squared. So I can distribute this, so it's going to be 12 minus 3x squared minus x squared. And then I can simplify that, so it's going to be 12 minus 4x squared and 4 minus x squared to the negative 1/2 times 2x squared, and that's my final answer. I can even factor out 4 if I were want to.
Okay, let's not do it for the fun of it.
Sure. So that's going to be 3 minus x squared. I can even simplify this more. So it'll be ax squared times 3 minus x squared over 4 minus x squared to the
How far do you want us to go on like a test? How far do you want us to go on a test? Like,
So here.
Why couldn't you just from the top, like, why couldn't you do what we were doing the other time, like, take out this and put up front? You know how you do? Like, the other questions we were doing?
Yeah, but the problem is the product rule. So one function times another function. So you have to take care of product rule first. So the product rule is, I do right, the left. So right, no, left, no, right. let's do whatever. I would just take the derivative of the left function first and leave the first part alone. Then,
At first I did the thing that we were doing.
yeah, but there's two functions here. If this is just one function, there's a difference. So now if it's one function, if it's just like this, you can just do the general power rule and they'll take care of it. But the problem is two functions. So you have to recognize when you have two functions, you have to recognize when to use product rule. So product rule is gonna be the derivative of this, right? And then it's gonna be, leave the first part alone, plus this part, and the derivative of this part, so it'll be 1/2 4 minus x squared to the negative 1/2 times negative 2x, which is the derivative inside. So if you did this part, that's the majority of the credit. Now you have to factor out the most negative, the reason why we can find the horizontal tangent that way. So if I take out this, then I'm gonna get this. Because the negative 1/2, negative 1/2. And then I'll look at a greatest common factor here, and I'll factor out another 2x squared. And then I got this. And then I simplify 12 minus 3x squared minus x squared. And then that's minus 4x. I can factor out a 4 over here. So it's gonna be 8, 3 minus x squared.
Do you want me to end the live stream?
Oh my god, I didn't end it